All right, now we're going to see how we can see if there's outliers or not. So I have that same data set with John Smith, who's really tall, in there. And I'm just going to make a graph of it. So we've done several graphs. So if I did a histogram of their heights, okay, it looks something like this. And we can see that there's not many tall people out there, okay, but not really sure if it's an outlier or not. I'm going to try a stem and leaf because we didn't have a lot of data. I'm going to do that for the heights. So when I look at the stem and leaf, we can see, yeah, that 90 is quite a ways out there, but we want to mathematically determine whether that's an outlier or not. So I'm going to switch screens here, if it'll let me. Okay, it's a little easier for me to type in a Google Sheet. So I'm going to switch to, I guess I got it over here. There's my Google Sheet. It's a little easier to type in this, but I just typed those same numbers over here for my distribution. So if I want to see if something's mathematically an outlier, our rule is 1.5 times the IQR. Okay, so remember the IQR is quartile 3 minus quartile 1. So 71 minus 65 is equal to 6. So I'm going to say that's equal to 1.5 times 6. So 1.5 times my IQR is equal to 9. Now, how you check for an outlier, you take that number away from quartile 1. So 65 minus 9 is actually, whoops, I got one number screwed up here. That should have been a 63 for the minimum. Sorry about that. Okay, so if I take that 1.5 times my IQR, and again, my IQR is 75 minus 61, 71 minus 65, sorry about that, is equal to 6. Take that times 1.5, I get 9. I take that 9 away from quartile 1, so 65 minus 9 is equal to 56. If I had any numbers smaller than 56, I'd call it an outlier. But my smallest number is 63, so that's not an outlier. Then I'd take that same 9, 1.5 times the IQR, and I'd add it to quartile 3. So 71 plus 9 is 80, and our maximum, or John Smith, is much taller than 80, so we'd consider him an outlier. Now, an easier way to do that is if I went back over and do crunch it, which I just have up here, I'm going to create a graph called a box plot for those heights. And I could give it a title. I could call it class heights. Now it makes a box plot of that. And all a box plot is the 5-number summary in a picture form. So if I pulled this, you can kind of see over there. Not exactly, but the minimum is 63, quartile 1 is 65, the median is 68, quartile 3 is 71, and the maximum is 90. So down here is my minimum, that's the end of the line. Here is quartile 1, here is the median, we use the median in the box plot. Here is quartile 3. Now this looks a little different out here. This line doesn't go all the way. So that point is the point where they start being outliers. So this shows you when you make a box plot and crunch it, if there's just a dot sticking out there somewhere, that's an outlier. So you don't even have to go through that 1.5 times the IQR rule, but you should know how that 1.5 times an IQR works, okay? So if I took that interquartile range times 1.5, it would get me somewhere here at like 80. But this line will go up to the largest value that's not an outlier. And if there's any outliers, they'll show up as a dot. So I'm going to close that for a second. I'm going to stick one more student in here, and I got to stick him at the bottom. So let's call this Short, and we're going to say his name is Jim Short appropriately. And Jim was only like 38 inches tall. Whoops, I got to double click. 38 inches tall. So we assume that that's an outlier. We'll have different statistics now. So let me get some new statistics. Okay, so again, my minimum is at 38. My maximum is 90. These change slightly. Okay, but now when I make my box plot for the heights, it shows that I have an outlier on the low side and I also have an outlier on the high side. So making a box plot and crunch it is just a picture of your 5-number summary. Minimum, quartile 1, median, quartile 3, and then the maximum. And if they're just dots, if the line doesn't go all the way to it, they're considered an outlier. Okay, so just one more graph here. I'm going to take out those outliers, those last two. So I'm going to delete that one, redo my statistics. Okay, so there's your descriptive statistics again. Now when I make my box plot, notice that there's just a line that goes all the way out to the end. There's no dots. So in our original class heights, we were pretty fairly distributed and we didn't have any extremely tall or extremely short people in the class last quarter. So this one would have no outliers because there's no dots on there. That's a quick way of checking for outliers, is just make a box plot.